Hello, good day. This short presentation about TRIZ for software innovation in IT. I'm Maciej, Jarosz. We'll come to that in a second, of course. Here's the agenda. Intro, you can see those points. Basically, I will try to introduce the short history and the context of using TRIZ, where it was used, where we want to use that, especially in IT software development domain. Then a short introduction about 40 principles, different tools, 2 exercises, etc., etc. Let's move on. Sorry for my voice. It can get pretty cold in here. Yes, intro. And that's, oh, sorry. That's about me, basically. Maciej Jarosz here. I'm a DevOps Institute ambassador for Poland, with many others. Of course, we promote DevOps Institute activities because it's worthy, and that knowledge is really valuable. So you can see whatever else I have put here. Basically, I work as an IT consultant, working with optimizing business processes, work processes, problem solving, creativity, etc., etc. And of course, best practices from the set of Agile, DevOps, ITIL, yeah, all that jazz. And then previous activities, of course, included delivering DevOps trainings, also IT trainings, and working in IT for something like 10 years. Time flies by. Let me check the clock. It's okay. Yes, send contacts to me. So, TRIZ, short history. That's the creator of TRIZ is, of course, Heinrich Altshuler. There are different pronunciations of his surname. Basically, the TRIZ is a theory of inventive problem solving. There are, different monikers that you can call it, like this Russian one, the original. What I would like to tell you here is that there are basically many variants of TRIZ. The classical one is has been codified up to the point when Altshuler passed from this world. So that's the classical set of tools, methods, philosophies, etc., that comprise the classical TRIZ. But of course, various different authors created their own mutations, let's say, some more complex, some less complex. And of course, some researchers try to somehow use TRIZ tools and methods in the software development domain, which is pretty interesting when we look at it. Yes, this is the recording, the pretty old one, I need to say. Altshuler teaches TRIZ, highest quality, which is not really high, but you can see the man live on camera. It's a really old recording. So, 40 principles. It's like a set of various actions that were taken to do something, or components that you can put in a device. For example, Altshuler researched, well, history says, or anecdotes, that it was something like 40,000 patents in the Russian patent office, and he aggregated those similar actions that were taken, or similar components that were put in the device, in the patent, and he composed a list of different principles that you can use in order to solve a problem, because well, in a way, a new device, a new patent solves something that has not existed before. Okay, the problem was before existing, but now we have a device that solves it, or the whole problem, or the situations. So yeah, now we have those principles like segmentation. For example, you can have one bus, like one module, but you can add this module in the middle, which would connect like 2 different modules, and now you have a longer bus, like public transport bus. mediator, something that will act as a medium in transferring the, for example, data, energy, whatever. I would like, well, I would ask you to research those yourself, because those are pretty useful, even if you're not like in mechanical engineering or electronic engineering. Those can be even pretty universal, I would say, to use outside of engineering context. Like do it in reverse. Well, pretty simple. Just reverse the order of any process that you are doing. Maybe you'll have different thoughts about the process, or take the action beforehand, or take the action after something happens, copy something, etc. Those are pretty universal operators, I would say. There are, of course, various other TRIZ tools like ideal final result, root contradiction analysis. So it's not like root cause analysis. It's like a more pumped up version of that. ARIS, like the whole algorithm of solving problems. It's pretty clunky. It's really heavyweight, so to say, but it brings results. If you can invest your time in learning ARIS or just applying it by the book, then you will have your results, of course. You can also analyze resources that you have in your environment and how to combine them to get new results. For example, contradiction matrix, the universal tool, so to say. There are many versions of that. S-curve, so how systems evolve into ideality. Standard solutions, substance field analysis, field called TRIZ business matrix, and more. Once again, I would like you to research that yourself, because I'm not spoiling the fun. I'm just giving you some hints that TRIZ is really useful in your context. Pretty much, you don't need to be like TRIZ lifelong expert. If you just read one book or maybe two or even half of a book, then you would get new heuristics in your mind. Heuristics, yeah, that's how they call it. Or other thought patterns that you can use to solve problem or ideate more creative solutions. Exercise number 1, like imagine you have a laptop, or no, well, you have a laptop. You produce laptops. You want to sell them, obviously. So how to make them more competitive? Well, you think that laptops with longer battery longevity are basically, well, better to sell. More, how they call that? People want them, basically. But the larger the battery gets, of course, the battery longevity would be bigger or longer in that case, but the overall weight would increase. So what would you do in this case? Well, maybe use some smaller batteries. Yeah, but those are expensive, more expensive than those bulkier ones. How would you like to solve this contradiction in a way? How to make it more competitive without making the laptop heavier, or without making the whole price of the laptop go up? Because if you use more expensive components, the price needs to go up. So the costs are moved to the consumer or the client, or however you want to call that person that pays. Yeah, what now? Take a moment. You can pause this video and then just think about it. What can you do to make it more useful for people, basically? Or maybe what to do in this case to increase the battery longevity and yet do not increase price of components. If you take a look at those principles, even without explanation, some of them may be pretty obvious and self-explanatory, like counterweight or prior counteraction, or, well, do it in the reverse. Yeah, just think about it. So that's the exercise without the answer, because you need to get the answer yourself, or just look it up online. but don't take shortcuts, because the journey is more important here than the results. I mean, not than the results, but than the destination. TRIZ, is it only for the physical engineering? Well, those methods are in use for something like 60 years, if I'm correct. Mostly in mechanical engineering, electronics engineering, or electronical engineering, biochemistry, chemistry. Well, basically, engineering domains that are palpable, that you can, touch them, you can see them, those molecules or whatever you're working with. So you can use those actions pretty much, those 40 principles or other tools, pretty much the same as in mechanical engineering, for example. But how does it relate to software engineering? Software, it's not palpable, the code. Well, of course, it's like a bits and bytes on a hard drive or solid state drive or whatever else type of storage you have there. But unless you power up the device, then you cannot really see the code. It's somewhere there, of course. So how to transfer those various different TRIZ tools into software? Let's try an exercise. Click. Yes, exercise number 2. Look, you work on an application, something like Uber or Uber, Just Eat. Just people order things, or they want to move a thing from point A to point B, like furniture, for example, because you're moving out, or maybe you want a taxi service, so you want to move yourself from point A to point B, or you just want to order, I don't know, a pizza, whatever you like. So you have this kind of application. Now, the main problem with that is like there are issues with pairing your users to your customers. So the customer would be a person who pays you for the use of your, well, for the privilege to use your app. In turn, you give the customer the whole market, basically the whole potential to get various jobs on a small scale, like a city level, let's say. Yeah, like imagine London, for example. And the users are the people who want something moved from point A to point B, so they pay the delivery man, of course, or the drivers or suppliers, or whoever is doing the job. And now customers complain about long acceptance times. So if you see the job, if you want something moved from point A to point B or order something, well, you need to wait a long time to get a match between your order and the delivery man. And that's a pain. And the users complain about, sorry, customers, users. So basically those delivery people complain that there is too much info to process during doing something before being able to decide whether to take the job or leave it. So imagine like if you would be a taxi driver. Okay, so you're driving people around and you see on your smartphone or on the tablet a new proposal for a job. Okay, so you need to check. Well, it's from point A to point B. The pay is something like that, like the approximation of the payment that you get. And there are so many potential information that you need to process while driving the car. So it's relating to safety issues. Well, I think that the drivers should not be distracted by too many things, especially too many things that they need to break the eye contact from the road in order to be able to see on their smartphones. Yeah, that's pretty dangerous. So what would you do in such a situation? Imagine you can change the user interface. I will just give you hints here. Or maybe you can change the algorithm. Maybe use some kind of data gathering, history analysis, and modify the algorithm in a way so those drivers that do repeatable tasks like taxi drivers or delivery people, so that they would have automatic acceptance of jobs that are similar to their profile or close to their preferred customized parameters that they set. Like, for example, always accept jobs from this this precinct, or skip jobs that involve I don't know, delivery of food. Yeah, that would speed up things. But there are many others potential solutions. There are various attempts to approach TRIZ in software development domain. But first, is software engineering a science or an art? Now you can talk with your colleague and argue. Just don't get angry at each other if your views on the topic differ. I'm not going to dabble into that. Well, in my opinion, it's obviously a science, like a computer science, of course. But yeah, we can say that a good, for example, developer will somehow creates an art piece, like a painter would create an art piece by following some techniques, but you know, adding the personal flair to that. Okay, that's only an opinion. How IT patterns and good practices map to those 40 principles. Can we treat good practices from various domains as patterns, principles? Like if you would think about, let's say, ITIL, or various others, bodies of knowledge. You have some good practices, prescriptions of what to do in any given way, any given, I mean, case, scenario, context. But is it repeatable? Is it context specific? Do you need to modify it in a way, or not? Are those like those principles from TRIZ, those good practices? Hard to say. Do we all, like in ideal context, for example, I think that having an SLA is helpful, or the operational level agreement. Why not? But is it always helpful? Hard to say. So by using the revert action here, can we treat the anti-patterns like patterns but in negative? So what not to do, of course, but if it's repeatable, then it's easier to see that happening at a given time and given space. So what to do then? Well, let's see how different researchers approach the topic. Hartmut Beckmann, the man tried to, I think it's still trying, those are screenshots, pictures taken from his articles on ResearchGate. You will have the source slide at the end. The man's trying to map those 40 principles to the IT domain, like principle number 1, 2, etc., and map it to various contexts within the software domain. But we need also to have in mind that he's using something like abstractions of physics. Like on a physical level, you have transistors, of course, voltage, blah, 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 optical, electrical interfaces, microprocessors design, whatever you see here. But on the information technology levels, what do you have? Bits and bytes, logic operations, assembler commands, algorithms like software, distributed computing like cloud. So the whole perspective is a bit broader than just simply mapping those principles to some occurrences in software domain. Like for example, you would be able to use a principle number 1 segmentation in different ways on those different levels of abstraction here. So bits and bytes, algorithms, etc. What else? He also proposes some kind of analogy of system characteristics, like physics and chemistry. You have objects, fields. I'm not an expert in physics nor chemistry, so pardon my negligence here if I'm saying something that is obviously not correct. But I'm not an expert in those domains. In information technology, you have objects, so any equipment able to provide or process binary data. Physics and chemistry, characteristics and status of an object or field. And then you have data and information available in binary format. How can you tackle the data? How can you make it work to do your stuff, to do your bidding? Good question. Then you have interactions between objects and processes inside some kind of a system. And here you have algorithms and a sequence of well-defined steps performed by objects using data. That's one approach. If you're interested in that, well, I would point you to ResearchGate or contact Mr. Beckmann directly. Then we have Daniel Kluender. Sorry, I cannot pronounce the surname properly, I believe. How to use TRIZ in IT architecture. That's a more specialized approach. Like, for example, what is architecture? You want to design a system with specific qualities in mind, like testability, dependability, performance, marketability, ease of use, some system qualities, like from the hardware side, like mountain space, how many servers would you need, or other components like storage, and would that be heavy or light? For example, what's the code size? Is it distributed? Is it local? Etc. etc. So Daniel mapped some attributes here to those qualities in software architecture, and basically by comparing those to those 40 principles and various other TRIZ tools and methods, you can think in different ways about those various qualities in software architecture. If I remember correctly, I think that you can even use the contradiction matrix here. But yeah, once again, I would point you to the source on ResearchGate. Then you have Darrell Mann research, software engineering matrix. Oh, sorry. Basically, Darrell mapped his own inventive software principles. Some of them are similar to those of classical inventive principles. Some are more specific to the software domain, like counterbalance or remove tension loop, slightly less, slightly more, vibration, enrich, etc., paradigm shift. Yes, and also Darrell invented software engineering matrix. It's described in a separate book, but I think that's a good point to research in the future. I'm also like studying this approach right now. It's it's really long. The book is very big. But well, the more the merrier, I would say. So I'm always open to new knowledge. Why not? That's something that you always profit on. So that's the third approach, and there are very many various others approaches, of course. Just for example, search on ResearchGate. Yeah, that's the end of this short presentation, the beginning of your journey, basically, hopefully. Why stick to brainstorming? Like, brainstorming is like, it's so crude. For example, I would say you can never get a decent idea by using just random idea generation. You would need to use some methodological approach to be able to create decent solutions or innovative solutions to solve your problems or to make a market profit from them. In this case, I would suggest that you at least try learning TRIZ, at least in a basic way. As I've said before, if you would read half a book, you're smarter from the knowledge that you've gained through reading half a book, because it's methodological. It's transferable to the business domain, for example, like Pavel Livotov created some TRIZ business rules. It's really useful. So why not use that free knowledge? Just invest your time and you will get your results. Yeah, here are the sources. You can type them. Those are pretty standard, I would say. Yeah, and that's all. So thank you for listening. Thanks to the organizers for inviting me here to give this short presentation. And who knows, maybe we'll see each other on one or the other conferences. Time will tell. Take care.